Hi everyone, my name is Emily Wade and I am going to present to you today my final project for my Engineering 340 class, which is Operations Research here at Liberty University. And with that said, I'll go ahead and get started. I did my project on farm planning, and the guidelines for the project were we were supposed to pick an example code out of the IBM OPL software, and we're supposed to pick a code that we thought was relevant to our lives and that we thought that we could either improve by adding another constraint that we felt was left out, or we could take a different approach to solving the problem. But I decided to do the first, so I will go ahead and dive in to how I did that. So my problem description was quite simple. The point of my project was for a farmer whom I called Tom. He wants to know how to operate his farm over the next 5 years in order to maximize his profit. So there are a bunch of constraints and conditions that go into farming and operations and farming, and some of them, the key ones, are in these tables below. You can see the labor requirements, because each heifer or each milk producing cow takes so many labor hours, and then each acre that is devoted to grain and each acre that is devoted to sugar beet also takes labor hours because of the farming that has to go into growing those feeding substances to get them to the cows. And then over here we have some costs and just how much each of the cows cost. You can see the heifer costs 50, the milk producing cow costs 100, and then you can see the acres for the grain cost 15, and each acre for the sugar beet costs 10. And those were just some of the simple constraints and conditions I was given. I'll go into more detail about more of the constraints in the later slides, but here was a very good problem description, and it lays out what I started to work with. So here's some variables that I have for my project. As you can see, there are a bunch that go into seeing how you can maximize the profit of a farm. You have your X sub TI, which is the number of tons of grain grown on the I amount of land in year T. And then you have Y, which is the number of tons of sugar beet grown in year T. And Z sub T, which is the number of tons of grain bought in year T. S of T, which is the number of tons of grain sold in year T. U of T, which is the number of tons of sugar beet bought in year T. And then you also have that constraint for V of T, which is sugar beet sold. And then L is the extra labor recruited in the year in units of 100 hours. And then M of T is capital outlay in year T. And then N of T, which is, we're getting to some of the really important constraints, which is the number of heifers sold at birth in year T. Q sub J sub T, which is the number of cows of age J in years in the specific year of T. And then R sub T, which is number of cows of age 0 in year sub T. And of course, the most important, which we're trying to optimize, P sub T, which is the profit in year T. Now, like I said, we were supposed to pick a topic that was important to us and that we felt that we had a passion for. So I chose farming because I've lived on a cattle farm my whole life, and eventually I will take over the farming and I'll inherit the family business. And this project just appealed to me because I would really like to maximize my revenue when I start farming. And here's some pictures of my cows from home. So the comparison with the as-is model and the to-be model. As-is, the model is based on the following conditions, which are just the initial conditions, the accommodations for the cows, the grain consumption, the beet consumption, the acreage needed to have the cows, the labor requirements for all the cows, and just the total number of cows in general. But I would like to add another constraint to the model. This model, nowhere could I find it modeling a major bull, a head bull for the farm, which if you're in farming, everyone knows that's a very important part, is to have a strong bull that can produce many cows over the years. And you have to get a new bull so often because you don't want your herd to be unclean and having the bull have babies with babies that it produced. So I thought that this would be a really good constraint to add in that was left out. And then I would also like to just see what would happen when you run the farm for more than 5 years. So I said 20 just to make it kind of a big assumption that the conditions will stay the same during those 20 years. But I'm going to run the farm for 20 years with the bull added in. And here's the mathematical model, the as is. And at first glance, it seems really complicated, but once you get down into it, it really wasn't that bad. As you can see, you have the major constraints, and you have your accommodations for all the cows, your grain consumption, your sugar beet consumption, and then you have your grain growing. So X1, X2, X3, and X4 are all different plots of land that can hold different amounts of grain. So you have those constraints, and then you have your acreage for your overall just cows in general. And then over here you can see the labor constraint for all of your cows, and for each type of cow, your heifers, your milk feeding cows, also for your sugar beet farming and your grain consumption farming. And then right here you can see the constraint that you cannot have more than 175 cows or less than 50 cows on your farm. And then here's the objective function, which is the profit function, and we're trying to maximize. So as you can see, here's the profit for selling heifers, selling the 12-year-old cows, selling their milk, selling grain, selling your sugar beet, and then at this point it switches over to your costs. So the grain you bought, the sugar beet you bought, the labor you had to provide, the heifer costs, the dairy cow costs, your grain costs, sugar beet cost, and your capital cost. So the mathematical model to be, this was kind of my whiteboard idea. I wanted to have, like I said, the maximized profit for 20 years instead of 5, and then I wanted to add the variable B for bull. And then I had to do a little bit of research, and the average cost of a bull is around $3,000 in US money, or about 2,829 euros. And then the average healthy lifespan of a bull in its production is 10 years. And so this would be an added cost, so you would subtract this constraint from the total profit at the end. And here's my possible model, but as I was reasoning through it, I realized that that was an incorrect just representation of the actual variable for bull and what it needed to be. So I modified that, and right here you can see this was some of my code. Here was my bull constraint, and I found that it had to be this type of a float because of the integers that it had in it, and because of the y in years, the y variable that it had in it. And as you can see, I set a float for bull price, and this was the price of one bull, which was the 2,829. And as you can see right here, this float bull time is as you can see, it's right here in the equation. So the overall equation is the sum of the bull price times the number of years over the bull time. So in order to get that variable, I multiplied the number of years, which was 5, times the average lifespan of a good healthy bull, which was 10. So that gave me 50. And then as you can see down here, we have the constraint added into the objective function for the profit. So we subtracted the bull's constraint that we created right here. So at this time, I'm going to go into OPL and just show you my code and just let you check out how I did it. So right now, this is the model without any changes added to it, and you can see all of the different variables being declared, the different constraints, and then this is the profit the profit objective function. And so I'll go ahead and run this for you. So we'll do run, default run, configuration. Okay. Shouldn't take too long. And here it is. Here's the solution with objective function. So this came out that the maximum profit for the farm for 5 years without the bull constraint is $121,719. And so now I'm going to show you how I added in my constraints. First, I'm going to show you where I added in my new variables. So we're going to scroll up here, and here's my float bull price variable in the bull time variable. And then I have the constraint copied right here in a notepad. So I'll copy this and I'll add it back to where I had it when I was testing it right here. And then we can't forget to add the bool cost to the objective function. So here we go, I added it in right here, so subtract bulls. And now this is for 5 years, and we'll run it and see how big of a difference it makes. Shouldn't take too long. And as you can see here, our expected profit is now $117,475. And if we take a look at what it was, let me switch back over to PowerPoint. It was 121,000. So that's quite a difference in the amount of profit that you would make. So now with the bull constraint added in, I would like to now run it for 10 years. And I'll go back to OPL and show you how I did that. Now, you have to go into the farmplanning.dat file where they have all their integers declared and their variables declared. So right here you have the number of years, and I'm going to change that from 5 to 20. And then I'm going to come back over here, and it should be set to run now. So let me take a snippet of this value so we can remember what it is. And let's run this now. Shouldn't take too long. So now the solution with objective is $270,000, and we can scroll down and see what the amount for the bulls cost was. So it was about $11,882. So that's how much less money they will be making because of this added constraint. But it is a very important added constraint, and you really had an inaccurate model without taking into account what the bull would do. So through this project, I learned a ton about OPL coding. I learned how to just be able to look at a code and decipher what it meant. I learned how to distinguish between the different types of variable declarations, and I learned that you had to have this type of float in order to have this type of a constraint in there. So I really learned a lot through this project, and I had a fun time doing it, and I hope that you enjoyed watching this video. Thank you.